Hey everybody, welcome back to Everything's a Project. I started working on the collet stand for the 22J collets, and so I've been cutting material and prepping the edges. So I'm just going to show you real quick again my vacuum system. Again, it's always a work in progress. I've been wanting to organize my grinders better. Right now they're just sitting on that table, but I've been using them a little bit, so I just ran that extension piece. You know, I didn't cut it to length, but it's in the zone and it helps, and it's still pretty strong. I have some gates. There's one there that's open. There's another one in the back over there that's closed because that's more for the cutter grinder. This one I don't have a gate on it yet. It's open. But what I've learned about the vacuum stuff is you don't want to deadhead it. So this still pulls, and it's got a lot of surface area, so it's not real strong, but on this machine the sparks are directed right into it anyways. But over there, it's surprising how strong it is. So, you know, I got this way in the back there, but I got my extension tool for turning it on. Oh, before I do that, in the background you can hear the filter. That's the air exchanger. That filter, now the filter that's in there started as a green one, but usually they're white. And they're as white as that paper. That's not a lot of use. So I've done a little bit of welding and I've done a little bit of grinding, and you can see how much it's pulled out of the air. I still wear a dust mask when I weld and grind. I have that. I have the dust collector. And so, you know, a lot of people always talk about safety glasses. I'm more, well, I protect my eyes. I've never gotten anything in my eyes, but you also have to be cognizant of what you're breathing in and your hearing, because those are the things that get you over time. You know, you get something in your eye, you know it right away, but crap you breathe in will come back 30 years from now. Hearing will degrade over time. I've worked in auto body shops. I've been an airframer in the Navy, so I worked around jets on an aircraft carrier. Was infantry, so a lot of weapons, lots of firefights in Afghanistan. Always around machinery, and my hearing is still good. As a matter of fact, when I got out of the Army, because I was infantry, they assumed that they were going to give me 50% disability just for my hearing. And I was reluctant to do that because I thought it might impair me from getting jobs. And of course, the first job I go and get, I had to go get a hearing test. So I didn't opt for that. I had 10% because when I got out, my ears would go, they would just go quiet for a moment, but no ringing, no tinnitus or anything like that. So, show you, so I use this rod, and that's my on-off button, and I try to do it gentle so I don't damage it. That's spooled up. I'm just going to show you real quick the grinder. Well, let me move in real quick too. Hang on. So I really like this buck tool grinder. I don't really use the stone, but the belt setup is great. It's a 2" by 42. Instead of building my own 2 by 72 or buying one that's $3,000 bucks, you know, this was like $250. It works great. I do almost all my work down at the radius down here, and it instantly radiuses your parts. You know, breaks the edges on them. And then a little bit up here on the platen if I gotta kiss a face. And then this is a soft deburring wheel, and that's a wire wheel. These used to be set up better, but I had to change my tables around. So I'll just show you one piece real quick. Watch this here. Here's a piece of 80 grit sandpaper, so it's kind of heavy. So it's got good suction, so if I make any type of enclosure here, or however I decide, this is all still fluid. I don't know exactly how I'm going to do it. But I'm getting tight on room, so this is probably going to be where it's going to be, but I'll have to make it better. Just real quick, I'll go over doing this. Put this down here. Just knocking the burrs off. I usually run that dust collector for a minute or two after, just to get anything that's lingering in the air. And then I run the air exchanger up to an hour after I do work. So that piece I was just sanding on, that's the for the feet, so that'll get the casters. When I did the 5C, I did it hastily and I just welded them on. I technically have a rule that I don't weld casters on because a lot of times you want to change them. You know, over time I found different ones that work better. So I try to bolt them on, and this stuff makes it easy. I got this as a remnant of 20-inch length, 1 inch by 4 inch for $1 a pound, so that was worth it. 40 pounds of it. Okay, so then this piece here is this is going to hold the aluminum plates that have the zoomed it in. So there's going to be aluminum plate on the top and bottom of this, and that'll guide the collets. If you just have one plate, then the collets kind of flop around. At the moment I don't know if an inch is enough, because those collets are really big. They're like 4 or 5 inches long, and if it needs to be longer, then I'll just extend this, have some extra of this, and it won't have to be full length. This is full length because it the top plate will bolt to it, and then here is the back mount, and then I got to determine the angle, what's the best angle to fit everything together, and then that second hole will get done. So these are 1/4 by 20 holes. This is a 3/8/16. The framing is going to be 1 inch thicker walled tube, and so you'll bolt through the tube into this, here and here on both sides, two decks, and so it'll get rigid pretty quick. So I'm almost done with these, so I'm just going to show real quick doing that. So 3 holes. I did the first one. This is the middle one. Essentially, I do as much stuff as I can from the center. So this is 0, 0, and then 825 thousandths, or sorry, 8-inch 250 thousandths each way. And when you do things from center, when they're multiple pieces, they'll go together. These holes on every individual piece will always be the same distance from each other. Okay, so around 670 RPM. I give it a kiss with the drill. This is a number 7 drill for 4-20 threads. Got good chip action. And brush it out of the way. Makes a little heat, but these are cobalt drills, so they don't mind it. If you're using regular high-speed steel, then you might have to date it a little more, use a little more coolant, or the anchor lube. I've complained about the anchor lube in the past, but I like it better than some of the others. I did a comparison with the tap between anchor lube and cutting oil, and the anchor lube does just as good. The oil gets everywhere, it smokes, so I'm sticking with the anchor lube right now. So what I do is, I don't have a 1/4-inch tap that wants to go all the way through in a shot. My 3/8 tap has no problem just feeding it right in. So I'll get it started. You'll see it slip, and then I stop when it slips. And the nice thing about this E-head is as soon as you shut it off, it stops. There's no wind down like with a traditional Bridgeport head. So it's real good for tapping. And when you tap, you're always pushing down. It started to slip, so I stopped because I don't want to break the tap. You're not going to get that out easily. When you are tapping with the head, you want to always keep pressure in the direction that you're going. So downwards for tapping in, and then upwards for tapping out. And I could have backed this back and forth and worked it through, but when it's starting to pack up some chips, I want to be able to feel it. So like right there, it doesn't comfortably want to go anymore. So I want to back that off, break that chip. Now I'm getting a couple more turns on it, back it off, break that chip. Again, this isn't production stuff. I don't need to go balls to the wall. I want to conserve my tooling, and the biggest setback in a shop like this is breaking a tool in there. Because taps are made to cut steel, so you're going to be hard pressed to find good tooling to cut out a tap. You can do carbide, you can break them out because they're on the brittle side, but that takes hours sometimes. There's tap removable tools, but they're little tiny petite fingers. They're not really practical. In a full equipped shop, the easiest thing is just to EDM them out. Use an electrode that's just under the size, find that center, burn out nearly all of the tap, and then just cave it in and pull out the remainder that's inside the threads. So that wasn't too bad. Probably should should have started filming on the last hole, not the second to last hole. So just bear with me, we'll do one more, and then, because I want to roll right into prepping the foot pads for the casters. And again, I'm going to use my trick, the rag on the handle of the mill. And it's a lot easier on your hands. You know, I'm doing a lot of cranking. You can hear that noise. I bought what was supposed to be a good Taiwanese table feed, and it sucks. I couldn't get it set up right. The gears, the shim pack wasn't right, and then I even had a professional equipment maintainer come try to set it up, and he couldn't get it that properly. So eventually it's going to come off. This is only a 42-inch table machine, so I don't mind cranking. I mean, it's good exercise, I guess. I've said that a few times. Best exercise is a good day's work. Oh yeah, when I tap that, I do it around 100 RPM. So I'm back to around 670. Give it a kiss. The only reason why I do a kiss is one, so I know right where it's going, and two, to be a pocket for the anchor loop so that the tip of the drill gets the concentration of the anchor loop. That's where it's needed. It doesn't need to be on the sides, it doesn't need to be on the flutes, it needs to be on the tip. That's where all the cutting forces are. You'll also see I do have my work supported, because like I mentioned in another video, when you're hanging out of the vise, this is a big lever, so as you push on, it's gonna come up. It doesn't matter how good the vise is. So you just have, you know, get a set of jacks. These are my rough jacks, I guess you'd call them. I have a nicer set for more petite stuff or precision type stuff, but these do the bulk of the work. It doesn't have to be anything fancy, just to keep the material from pushing down. Back to the tank. Put in the anchor loop in the hole. So again, that you need the anchor loop at the beginning of the tap. Because that's, again, where all the cutting forces are. Okay, 100 RPM. Go down. Okay, I'll do the back and forth, so now we'll back it out just a little bit, not all the way, because then you'll have to restart it. And if you do go out all the way and you need to restart it, the best way is to just put the head in neutral and turn it in to pick up the thread, because you don't just want to wing it and try to go in again. And once you get a few threads grabbed, put it back in gear and then resume. So I was still slipping, so I'm not going to push it. So back it off. Yep, see, it's really tight. So break that chip. And the reason why I can't go all the way through with power is I just don't have a good 1/4 inch 20 tap. I keep forgetting to get them. I have ones that have been used before and they're not hot rods. This 3/8 one is great. This is for a through hole. So it pushes the chip out through the hole. And then if it's a spiral, those are good for blind holes because it'll kick the chip out the entrance. So I'm going to shut off that air handler. It'll be a little quieter in here. So right now, any noise you hear is the phase converter, the air conditioner, and then I use a little fan just to spread out, circulate the air for the air conditioner. I've been in here about a half an hour. I had it overnight. I had it 80 degrees in here, so now I'm bringing it down to like 74. The phase converter makes heat. You know, all these machines make some sort of heat, but nothing terrible. The phase converter is the most because it blows right down into where the new lathe is, that area. That alleyway between the two lathes. Okay, so that's done for that. Then I just break the edges. A lot of people will break the edges prior to tapping. It's not a bad idea, but unless you take the time to figure out how deep you need to go, you're gonna remove that edge break. I haven't had a lot of problems with hurting the thread, breaking the edge after I tap. And if I do, I can just go in real quick and clean up that first thread or two. So the only reason why I'm doing this without pre-doing it is just because I goofed around with it and it hasn't been a problem. A long time ago when I was in the tool and die shop, I calculated all the center drills so that I could determine the chamfer I'd get for how deep I went, you know, for what size hole it was being done for. You want to go through that trouble? Go ahead. I mean, if you're doing a whole bunch of these, then you can, when I say a whole bunch, it's more than what I'm doing here. Then you can figure it out, and then you can replicate it. But for this project, let's get it done. Okay, that's good enough for now. So these 4 pieces are done. Let's roll right into these feet. Now, one of them cut crooked, and I don't know if I cut it crooked or the material was and I didn't catch it. So that's the primary reason why I'm going to address these. Yeah, so actually I have 2 that are wonky. I have 2 that are near identical and 2 that are goofy. That happens. Don't do that. Here, you guys thought I was going to just push them right off the edge. Instead, I had to make it more interesting. Knock them around. These are really goofy. Okay, so what I'm tinkering with, you can see it. Sorry, this viewfinder's so small I can't see shit. So right here, these three are pretty square to each other. This one is way off. I don't know if you can see. Oops, it's just sliding, but needs a tilt. So I gotta come up with a way to tilt it. What I need to do is figure out how to project this camera onto the TV, so I can just look into the TV that's over my shoulder and I can tell what the view is like. Okay, so I don't have a giant. If I had another, well, that'd be a lot of work, but you can put another vise in here and clamp together. I think that's what I'm going to do with one of the cant twists. So I'm putting a 1, 2, 3 block on each side. I guess I'll have to use this big. Oh, I got. Let me get a C-clamp. I have C-clamps. So I have a real big cant twist, but it's pretty bulky. So I forgot about these, all these C-clamps I got. I got them with the, when I bought up that small shop. These were in the cabinet that the shaper was on. I did sell the shaper. And it's funny because I was complaining about potential buyers for the shaper and how goofy they were, and the transaction ended up going very well. Oh my. I'm off by like 1/8 of an inch. Let's see if one will do it. Now I sell stuff every so often on Marketplace. You get a few goofballs, but the shaper deal was considerably more than normal. So, I mean, I got tons of inquiries. People saying they're going to come by, and somebody asked me, is it for metal? I'm like, well, did you watch the video that was included? Okay, so that's not terrible. Let's see if I can tap it without knocking it wonky. That one wants to stick out. Okay, so that's not bad. So now it's smooth. They're just about equal at this end, but this front one is proud at this corner, and so that way I can cut that part out. And once I improve this side, then I flip it. Then it'll be easier to do the opposite side. So we're going to go back to my favorite roughing cutter. It does all kinds of work for me. Covered in chips. again. So our highest point is this here. So just lightly touch the workpiece, set my zero. Don't have to, you can just leave it where it's at and just keep track of it. Makes it easier. Lower it a little bit. Put it back in high gear. Come on, buddy. There you go. So we're 600 RPM. Go to our zero mark and see what we get. A little bit. Perfect. Okay. Go down 25, see how it cuts. So now we're raise the table 25 thousandths. I think we want a little more RPM. I love this cutter. I gotta get a whole complement of them. So just work this one piece. Up another 25. I don't want to go too much. I don't want to take the chance of kicking that part around. So now we're cutting on the second piece. That one was also proud, but not crooked, it was just tall. Generally goes pretty good to go in this box shape, clockwise. When I did that little seminar with the local metal group, they're trying to discuss and reason blind milling, conventional. Now be truthful, that confuses me, but I found that clockwise for facing and outside cutting works the best, and counterclockwise works the best for inside cuts. So like if I was making a pocket, let's zoom in. Sure, you don't need to be looking at me. I know some of you want to look at me. Are you looking at me? Yeah, this tripod doesn't go high enough. It'd be nice if it went higher, then you can get more of a bird's eye view, but I can address that sometime. I believe that getting good heat removal. The chips are coming off material color and then turning slight color as they set. So that means the heat's going with the chip. Yeah, so there's no heat in the block. And there's very little in the tool. So got a little ways to go. So I'm gonna stay with 25 thou at a time. Again, I don't want to kick the part around. That'll ruin my day. Set me back. I don't have enough material to make up more of these pieces, so I'll try to speed it up for the camera because the cutter is doing fine. I haven't really gotten into fly cutters. I have a few of them, but I know that a lot of people would do this work with fly cutters. Okay, the next cut will be into the other two blocks. So what I'm going to do for this next cut, I don't need to take a lot off of the other ones. So I'm going to just try 15 thou. And I'm going to speed it up a little bit. That was at 850 RPM. So we're at 1300 now. And just so I get a nicer finish, doesn't have to be, but it's a little more than I thought. This will be the final count. 15 more. And I'll do this in lateral passes. So also when you go clockwise on the OD, you get a lot less of a burr on the edge of the part. If you go the other way, it'll force all the burr over the edge instead of breaking it. You'll have a lot more cleanup to do. Oops, I didn't mean to do that. I wanted to go back and forth. But I'll do that this way for the perimeter, that way I don't get the burrs like I just said. Now I'll go back and forth. So that's it for facing that first side. I'm feeling the chips because instead of brushing them around or dealing with them, I'm gonna vacuum them up with my beautiful vacuum. Okay. And one of my other pride and joy is the vacuum. And I have it on the remote. It's central vac over mounted on the wall on the other side. 25-foot hose reaches everywhere in the shop. It'll suck up anything. When I say it'll suck up everything, I mean it'll suck up everything. If I think I'm getting an obstruction, I take a random nut and I toss it in there. And half the time it'll knock out the obstruction and I'll hear it hit inside the vacuum and I know I'm good again. It'll suck up C's and 6s all day long. Doesn't like the little swirly bits you get from drilling or bird's nests that sometimes you get from milling. And usually those are big enough where you can just pick them up with your fingers. Like here's some that were down in the T-slot, and I just throw those direct in the can. It's better to vacuum than it is to blow, because when you use a blow gun, you push chips abnormally into areas that they wouldn't go into. So you force them into the seals and the ways. And in my case, the vacuum is kind of, or the air compressor is on the noisy side. That way I don't have to do it. So done with the C-clamp. Set that aside. Brush out the little bit that's still in the crevices before we remove the part. That way it doesn't fall into the vise where we got to deal with it again. Okay, so we do have to address the burrs. So we will I'll use the file. I was going to use the burr wheel, but then I got to switch over the camera. Yeah, I do apologize for the crappy camera work. You know, I keep saying I don't want to put all this effort into it, but yeah, when I showed off the setup for on the lathe for the follow rest and steady rest and let the camera swing, yeah, that was beyond amateur. And I don't mind, a person did comment about it, and I don't mind that because it does confirm that I need to take that into consideration. Right now, I'm real light on horizontal surfaces where to put stuff, so I couldn't just have set it down at that time. But I'm gonna try to keep working on that. So I just want to get rid of any burrs that are gonna influence the part. Now they're all sitting in there square to the bottom of the vise. You know what? They actually run. What appears that has happened is when I use the 1, 2, 3 block, I improved the situation, but I influenced each block to each other. So the one block that was square, I canted that slightly, and I took some of the cant out of the other one. So I currently have 2 blocks that are still not square. I'm going to go back to the clamp. Now I'm going to make sure I get 3 of the blocks. They're not real bad, but I might as well take this chance to... Oh, you know what I'm doing. What a dipshit. Because I was intent on using the 2 blocks. The one side of the vise is only touching 1 block. That doesn't work. Let me go to my pile of setup stuff. Here we go. Got a burr on it. So I got a thin parallel type material. cut down at one time. There we go. So I'm going to see how this sets up, then I'll probably shut off the video, do the cuts, because it'll have to get flipped one more time. But this is there. Like I always say, everything's a project. If it's not, I'm going to make it. Okay, that's what I should have done in the first place, is had something that went across multiple pieces on both sides. So my original idea was okay, but I failed when I pulled out that 1, 2, 3 block. Okay, so now tighten it down, give it its love taps. Okay, I'm going to tinker with this. I'm not real happy with what I'm getting. If they weren't so large, I would put them on the good end on the floor of the vise and then cut along the side. But I do have long cutters for that type of stuff, but it's kind of it's tough on the machine. As I'm saying that, I could also just put one at a time. I have to do that. Put them up on parallels. Do one at a time, just to square the face, and then stack them. That's probably what I should have done. I should have done individually. Cleaned up the ends so they're square to the two sides, and then put them how I have them now, and then match them all together. So that's the deviation I'll probably make, and I'll get back to you tell you how that worked out.